So this is a trinket representing the movement of a ball on a spring. And so within this code, line 3 represents the initial length, or the length of the spring, which is in 0.1 meters. K is the spring constant, which can be changed to become either more or less elastic. This is just, lines 6 through 8, just allows us to see the movement of the spring as it is, because it's giving us the size of the holder, the size of the spring, and the size of the ball. So that just makes it a lot easier to see what's actually happening. Line 10, this is the mass of the ball. Line 11, this is the momentum of the ball, which is equal to the mass times the velocity of the ball, which the initial velocity is 0 in all these components. Line 13 is the displacement of the spring. Line 14 is the momentum of the ball, which is equal to, this is the position of the ball, which is showing the original ball position plus the change in position. Line 16 is the force of gravity. This is just showing that the initial time is 0, and the change in time we made to 0.01 seconds. Now, line 20, this says t is less than 3, which means that it will run until it reaches 3 seconds. However, you can just as well change this to while true, and that means it will just go on forever. Then this, the rate, means that it is moving at 75 bounces per second. And then line 23, this is the length of the spring. Line 25 is Hooke's law, and this states that when an elastic object is stretched, this is the extension which is directly proportional to the applied force. So the force applied to it is going to explain how far it stretches. 27, this calculates the net force. Line 29, this updates the momentum of the ball. Line 31, this updates the position of the ball as it moves. And line 33 updates the movement of the spring. So with this trinket, you can use it in a variety of different ways to answer different questions. For instance, you can change the gravity, the force of gravity on the ball if you wanted to. You could make it greater, so let's just change this to 15. And you can make it less, or you can change the spring constant. You can make that larger if you want, and it being larger means it becomes less elastic. For instance, it doesn't stretch as far, it just does short bounces. And then you could also change the mass of the ball, and you can see how that affects the movement. You can change the initial length of the spring. You can change all these different variables within trinket. So this is saying that the mass of the ball is 0.5 kilograms, and then it's saying that the length of it is 0.4 meters, so it's really long. And then we have the spring constant as 65, so it's really, really not elastic. So if we wanted to, we could change this to make it really elastic, so it bounces really far. And we can see this just as well if it's at a shorter length. So you can see how stretchy it is there, and we can make this 65 for instance, and we can see again how not elastic it is. Well, compared to what it was, it's a lot shorter distance that it's bouncing. Then you could also change the position vector. Where is it? For instance, we could change this to 0.5. And we can see that it doesn't move as far as it did originally, whereas we can also make this larger and see that it'll move a lot farther.